Welcome to today's lesson. We are going to look at probability in two-step experiment. We've been looking at one-step experiment, but now we have two-step experiment. What do I mean by two-step experiment? An example could be that a person could be tossing a coin, and at the other side somebody is tossing a die. So we are having two activities going on at the same time. So when two activities that are independent, they don't depend on one another. We are having two independent activities taking place at the same time. Then we say that is a two-step experiment that is happening. So we are using an example like tossing a die and tossing a coin and rolling a die. So those are two events that are happening, but the two events are independent. They don't depend on one another. So in that case, we are having a two-step experiment that is being carried on. So how do we solve probabilities using the two-step experiment? It is easier for us to solve the probabilities in two-step experiments using a table of multiple events. So we are going to use a table of multiple events to solve the probabilities in two-step experiment. An example So these are the two outcomes we have. We are talking about a coin is flipped. We know that a coin has two sides, head and tail. Then, apart from a coin being flipped, we are having a spinner that is being spun. So this spinner has 1, 2, 3, 4, 5. So we need to list the outcomes in each case. So there is possibilities. These are the following outcomes. There is a possibility that head and 1 will appear at the same time. This is head and 2. We have head and 3, head 4, then head 5. Then this one is tail and 1, tail 2, tail and 3, tail and 4, tail and 5. So those are the outcomes that are expected when a coin is flipped and a spinner is spun. So part A of the question asks us how many from the experiment carried out, how many outcomes are possible. So it is just a matter of counting the outcomes we have in this given experiment. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a total of we have a total of 10 outcomes in this experiment. Part B of the question. So you list 4 outcomes in which an even number is displayed on the spinner. So the outcomes which have even numbers displayed. So the even numbers, we are talking about numbers that are divisible by 2 fully. The numbers that 2 will divide fully. So in this case, even numbers that have been displayed are h and 2 has an even number. We have h and 4, which has even number. 1, 3, and 5 are odd numbers. So moving to the tail, we have tail and 2, then we have tail and 4. So listing the outcomes that have even numbers, we have h2, h4, t2, and t4. So these are the outcomes that have even numbers being displayed on that given spinner. Part C of the question, after we've gotten the outcomes that are being displayed on the spinner with even numbers, we are supposed to get the probability. So probability that an even number is displayed. So even numbers are displayed in 4 outcomes out of a total of 10 outcomes. So number of favorable outcomes, in this case we are having 4. Total number of outcomes are 10. So it means probability that an even number is displayed, if I simplify my fraction, will be 2 over 5. So we list outcomes for which tails is flipped and odd number is on the spinner. So we are looking for specifically tail and odd numbers. So in this case, tail, we have 1, we have tail, we have that one. So it means that the list of events or outcomes that has a tail and an odd number, we have tail and 1, then we have tail and 3, and we have tail and 5. So a tail and an odd number, we are having 3 events, tail and 1, tail and 3, then tail and 5. We are looking for tail and odd number. So that is why we've listed the 3. 1, 3, 5. So that is, those are the odd numbers in that case. Then the question is, the next question after that is, we find the probability of probability that a tail and an odd number will show on that given diagram. So probability of tail and odd number will be obtained by, we have 3 possible outcomes out of 10. So this will be simply be obtained by 3/10. The fraction is already in its simplest form, so no need to simplify it further. That is one of the questions that is dealing with multiple events, but in this case we are only having flipping a coin and spinning a spinner. So we are having the two events. We've listed them down in the table. So we've used this table to list down our outcomes. Then using the table, we answer the questions that are required of us. Let us look at another question involving multiple events. So we have a 20-cent coin and a 50-cent coin that are being tossed. So 50-cent coin and a 20-cent coin being tossed. The outcomes are as follows. There is a possibility that the two will show the head. There is a possibility that one will show head and the other one tail. There is a possibility that the one will show tail and the other one head. Then there is a possibility of all of them showing the tail. The questions are as follows. So we are being asked for the probability that the 50-cent coin will be heads and the 50-cent coin will be heads and the 20-cent coin will be tails. So the probability that a head will be showing on the 50-cent coin and a tail will be showing on a 20-cent coin. So what is the probability that we are having a head and a tail showing? So we get that probability that a 50-cent coin is showing a head is, we are having the first outcome, head and tail, 50-cent coin. So 50-cent coin is here. The head for the 50 cent is there. So we have that outcome that the 50-cent coin is showing the head, the 20-cent coin is showing the tail. So probability that the 50-cent coin is showing the head and the 20-cent coin is showing the tail. Here we have the 20-cent coin has a tail, the 50-cent coin has a head. So we get that we have two outcomes where we are having a head showing on the 50-cent coin and a tail showing on the 20-cent coin. So that means 2 events out of 4 events. So the probability that we will be having a 50-cent coin showing head and a 20-cent coin showing tail is 2 out of 4, which gives us a half. B, we are asked for what outcomes? For what outcomes are the coins? Are the coins showing the same face? So which outcomes are events, are the coins displaying the same face? So we find that we have an event where the 50-cent coin is showing the head, and we also have an event where the 20-cent coin is also showing the head, and another event is where the 50-cent coin is showing a tail and the 20-cent coin is showing the head. So we have two events that are showing the same face, and these events are the head and head for the 50-cent coin and 20-cent coin, and a tail and a tail for the 50-cent coin and the 20-cent coin. So two events that are displaying the same face on the two coins, that is head and head and tail and tail. The probability of the two coins displaying the same face, we've already found out that we have two outcomes where they are displaying the same face, and total number of outcomes are 4, so we have 2 out of 4. If I simplify, I'll be getting a half as the probability that the two coins are displaying the same face. So question 3, we have a coin is flipped and then a die is rolled. Draw a table to list the sample space for the experiment. So we draw a table that is showing the sample space of tossing a die, and rolling a die and flipping a coin. So we have a coin and a die. We know that a die has 6 sides labeled 1, 2, 3, 4, 5, and 6. So that is a die. So we have a die on this side. Then a coin has 2 sides, that is the head and the tail. Head and tail for the coin. So the outcomes that will be present in this case, we have head and 1, head and 2, head and 3, head 4, head 5, then head 6. Tail and 1, tail 2, tail 3, tail 4, tail 5, and tail 6. So those are the possible outcomes for that experiment of rolling a die and flipping a coin. So we are having a die and a coin on this side. So we have a sample space of 12 outcomes in total. So that was part A of the question. Part B is requiring us to find how many possible outcomes are there. So how many possible outcomes? And we find that we have a total of 12 outcomes that are present. In that we are counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a total of 12 outcomes in that experiment. Then C is find the probability of the pair H3. So probability of the pair H3. So we find where we have H3. How many favorable outcomes do we have for H3? And we discover that we only have one H3. So we have one favorable outcome out of 12 outcomes. So if we are having one, then it means the probability of the pair H3 will simply be 1 out of 12 as our probability of obtaining a pair that is H3. The last part of the question, part D, we find the probability of flipping heads and rolling odd numbers. So we need to find where we are having heads. Then identify out of the heads which one are our odd numbers. And we started by defining an odd number as that number that is not divided by 2. So we get that the first odd number we have is 1, the second odd number we have 3, and the third odd number is 5. So we are looking for a head and odd numbers. So we look for head, not tail. We are looking for where we have head. So this is the first outcome. We have the second outcome. Then this is the third outcome. So we discover that we have 3 outcomes out of 12. So probability of rolling a head and odd number will be 3 over 12, which gives us 1 over 4 as the required answer. So a letter is chosen from the word line and another is chosen from the word ride. So we are asked to draw the table to list the sample space. So we have the word line and we have the word ride. So we draw that table showing the letters. So we have letters, that is line. Then on the other side, we have ride. So we have line and ride. We are showing our outcomes on that table. So we are using the table to show the outcomes that are expected. So there is a possibility that when a letter is chosen or letters are chosen at random from the two words, there is a possibility that R and L will show, R and I, R and N, then we have RE. Alternatively, we can have IL, II, IN, and IE. Then we have DL, DI, DN, and DE. Finally, we have EL, EI, EN, and EE. So the questions are as follows. From that drawing of that sample space, we are asked how many possible outcomes are there. How many possible outcomes are here? So we count the number of outcomes. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have a total of 16 outcomes in that sample space. Then part C of the question, we need to find the probability. We are finding probability of NR, probability that N is chosen from the word line. So we have N is chosen from the word line, probability that N will be chosen from the word line, and R is chosen from the word ride. So this one, N is from the word line, and R is from the word ride. So we get the probability where we are having N being chosen from the word N, from the word line. So we find where we are having N from the word line. So this is our word line. N is here. Then probability of R being chosen from the word ride. So this is the outcome where we are having N and R being chosen, N being chosen from line and R being chosen from the word ride. So the probability, we are only having one outcome out of all the outcomes we have. So it means probability of choosing NR will simply be 1 out of 16. Part D of the question. Part D, we are to find the probability of LD, where L is being chosen from the word line and D is being obtained from the word ride. So probability of LD, L from the word line and D from the word ride. So we have also in this case, we only have one outcome out of the 16. So it means probability of choosing LD is 1 out of 16. So probability of us choosing LD will be 1 over 16. Part E, we are finding the probability probability that two vowels are chosen. So we need to know what are these vowels. So vowels in the alphabetical order, we have A, E, I, O, U as the vowels we have. So we find out in this case, where do we have two vowels in our outcome? So the first one, that is the first vowel we have. So this is the first pair of vowels that we meet. Then we have another pair of vowels at that point. Then this is also another pair of vowels. We have that as another pair of vowels. So those are the pair of vowels that we have. So we have 4 outcomes that are showing 2 vowels. So it means the probability will be 4 out of 16. So we have a total of 16 outcomes. So our probability will be number of favorable outcome, which is 4. Total outcome is 16. So we get that the probability will be 1/4 if we simplify. Part F of our question is that we find the probability that the 2 letters chosen will be consonants. So we are looking for 2 consonants. So we find out where do we have 2 consonants in this case. So this is the outcome. We have R and L. Here we have a vowel, so it will not be included. So this is another consonant. This one has a vowel, so we don't have 2 consonants in that case. In this case, we have a vowel, we have vowels, we have vowel here, we have a vowel here. So the next consonants we have is in that group. This one is also 2 consonants, and those are the outcomes that have 2 consonants. So this means that we also have 4 outcomes that are having 2 consonants chosen. So it means the probability will simply be 4 out of 16, which gives us 1/4. Then finally, the last part of that question is asking us to find the probability that the 2 letters chosen are the same. So probability that the 2 letters chosen are the same. It doesn't matter if they are vowels or consonant, but what we are concerned with is that they are the same letters. So where we are having the same letters, so an example is we have 2 eyes at that point. We are getting 2 letters that are the same. Then we have the 2 is in that point. So 2 possible or 2 favorable outcomes that are having 2 letters that are the same. So we'll have the probability will be favorable outcomes are 2. Total number of outcomes we have 16. So the probability will be 1/8. So we are having 2 dice being rolled for a board game. The numbers showing are then added together to get a number between 2 and 12. So draw a table to describe the sample space. So we are having the numbers being added. So we have a dice having numbers between 1 and 6. So we have the first die. Then the second die also has the numbers between 1 and 6. Then the instruction in the question is that the numbers that are showing are being added so that we are getting a figure between 2 and 12. So in this case, we need to identify which numbers are showing in each and every outcome. So the first outcome, we will have a 1 and a 1 showing. So the numbers are added. What do we mean? We have 1 plus 1. So that 1 plus 1 will give us 2. Then here we will have 1 and 2 showing. So 1 plus 2 will give us 3. Then 1 and 3 will show in this category. 1 plus 3 will give us 4. Then we have 1 and 4. So 1 plus 4 is 5. 1 plus 5 will give us 6. And 1 plus 6 will give us 7. The next outcome, we have 2 and 1 showing. So 2 plus 1, that is 3. 2 plus 2 will give us 4. 2 plus 3, we get 5. Then 2 plus 4, that is 6. 2 plus 5, we get 7. 2 plus 6, we get 8. 3 and 1, 3 plus 1, that is 4. 3 plus 2, we get 5. 3 plus 3, 6. 3 plus 4, 7. 3 plus 5, 8. 3 plus 6, 9. Then 4 plus 1 is 5. 4 plus 2, 6. 4 plus 3, 7. 4 plus 4, 8. 4 plus 5, 9. 4 plus 6, 10. 5 plus 1, 6. 5 plus 2, 7. 5 plus 3, 8. 5 plus 4, 9. 5 plus 5, 10. 5 plus 6, 11. Then 6 plus 1 is 7. 6 plus 2, 8. 6 plus 3, 9. 6 plus 4, 10. 6 plus 5, 11. And 6 plus 6, 12. So those are the outcomes that are obtained when the two dice are rolled, then the numbers obtained are added. So the question is, find the probability that the two dice add to 5. So the first question, we get the probability of the two dice adding to 5. So we are having finding the probability that the two dice add to 5. So we find in our sample space where we are having their sum as 5. So the first occasion, we have that. Another outcome is there. Then this is the other outcome, and that is the other outcome. So the outcomes where the two dice are adding up to 5 are 1, 2, 3, 4. So we have 4 outcomes out of a total of 1, 2, 3, 4, 5, 6. That is 36. So we have possible outcomes, that is 4. Total outcomes are 36. So 4 out of 36, if I simplify, I'm having 2 out of 18. Further simplifying, it means that I have 1 over 9. So it means the probability that the number adds up to 5 will be 1 over 9. Next is find the probability that the two dice add up to an even number. So we find the probability that the two dice add up to an even number. So probability of even So we find the even numbers in our sample space. So we get what are even numbers. So this is, we start with 2, we have 4, 6, we have another 4, 6 and 8. Then we have 4, 6, 8. We have 6, 8 and 10. This is 6, 8, 10. Then we have 8, 10 and 12. So how many favorable outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have a total of 18 favorable outcome over the total number of outcomes, which is 36. So 18 over 36, if I simplify, we are getting 1 over 2. Part D, we are being asked what is the most likely sum to occur. So which one is the most likely? What does it mean? Which one is occurring more among the numbers that we have? So we find out we have the sum 2. 2 has occurred only once. 3 has occurred twice. 4 has occurred 3 times. 5 has occurred 4 times. 6 has occurred 5. 7 has occurred 6 times. Then 8 we have 5. 9 we have 4. 10 we have 3. 11 are 2 and 12 1. So which one is the most likely sum that has occurred? We find that 7 has occurred the highest number of times. So we say the most likely sum that has occurred is 7. Lastly, what are the 2 least likely sums to occur between 2 and 12? So this 7 is most. The least that has occurred, the one that has occurred the least number of time. So we find out, we get that 2 has occurred once and 12 has also occurred once. So the 2 least occurring sums, in this case we are having 2 and 12 as the ones that have occurred the least. So we are simply saying this, that when you're having multiple events, we can represent them on a table. After we've represented the multiple events on a table, then they will give us the list of outcomes that are possible, or the list of outcomes that are likely to occur in those given multiple events. So this table simply helps us to get which are the outcomes that have occurred, and after we've obtained the outcomes, then it is possible for us to work out the various probabilities in 2-step experiments. So the table helps us to make the calculation of a 2-step experiment easier, because all the outcomes will be listed down in that given table. Then the probabilities of the given events will easily be calculated from the table. So that is how we get to work out probabilities of multiple events using a table. Thank you for listening.